I'm really looking forward to this next presentation. I'm sure as many of you in this room know that automated tools have done a great job at making our lives easier, particularly with repetitive or boring tasks. But most of the time, they're failing to give us a complete picture of the threats that are posed to organizations. So without further ado, jumping into that topic is the man to the left of me, Christian Neves, who is IT security analyst and incident handler at Compass Security, who of course is one of our sponsors. So let's give a big round of applause to Christian. Over to you, Christian.
Thank you. So we'll start directly. So when you have an incident or a breach, so like your security didn't work, so you have to handle a breach. So you have three essential goals. The first one is analysis, where you want to identify the infection vector and all the indicators of compromise. And then when you identified all your systems that are infected, you have to contain them and finally recover from them. So this is basically the incident handling guide from the NIST. And here we are going to focus on the analysis part of this handling. Because if you don't do an analysis good enough, you will have a system which will still have some web shell or some way for the attacker to get back in. So your containment and recovery didn't do much. So we have a quick introduction of infection flow of a well-known malware. This is Emotet. So basically, a user has a file. This is usually a Word document with a macro. This macro runs some code, PowerShell, exe, etc., which is called a dropper. So if you looked at the talk before where they were talking about AVs, not very clear what they are saying about the malware. If you see dropper in there, this is the type of file it's alerting you about. Then this type of malware, they simply download additional malware. This is to prevent the intellectual property of the attackers to get known quickly. These are all handled by servers that are compromised and or cloud providers, so Dropbox, AVS, etc. Then when they download the malware, this malware tries to get some information about the host or the system, and then it runs some persistence so the attacker can continue his process. This sends data to the C2 server, which is the command and control, and the command and control sends additional malware. This can be ransomware, other type of malware if they want to investigate more about the network, or just simple commands that the first malware can execute. And then they repeat this process, and this is what's called beaconing. So when analyzing a breach, we want to identify these four elements. So the dropper, so we can see what other systems are affected. Prevent the network flow, so what are the connections to the delivery servers. And then identify the malware itself, what it's doing, and if possible, the C2 hosts too. So now we're going to look a bit more in depth and then see what are the automations can do for us and what are the drawbacks. So for the dropper, we can just put this document in the sandbox, for example, which will do for us, will deobfuscate the macro and then show us the command that it executes. So we can see here it's a PowerShell script and with a base64 encoded command. If we base64 decode this, we have the actual code, which is, yeah, it's okay. And then if we have a look at what are the anti-automations on this code, we can see here there are two squares. So this is if you have a regex, so regular expression to find URLs on this code, you find only two matches. But if you look at it, you can say that there's more than two URLs. And on one of them, it's mixed with a good known URL. So if you automate the process of extracting URLs and blocking, you will block Microsoft.com and maybe have a bit of a bad time because some of your service won't work anymore. And in the case you only extract the domains, you will only have Microsoft.com and Dylan on this example because the URL is valid like that. And this is another way they try to prevent detection by having multiple URLs. So this is for two reasons. First one is to, in case one of the servers is get restored or is blocked, they can go through the other ones and still deliver the malware. And finally, we have here in the bottom, it checks the size of the response. And this is to prevent, in a sandbox, for example, we can block network. And if it doesn't receive the proper size that it's expecting, it just stops and might get undetected or considered not malicious. So if we go a bit further and see what our sandboxes gave us, so I have 3 sandboxes with 3 different results. So the first one just gives us one URL. The second one is from the C2. Another one gives us 2 URLs. And finally, one actually finds the 5 domains. So having automation tools is not always perfect. You don't always have all the informations, but you know that it communicates with the network. So you can just give this to an analyst, and he looks at the code, and he can quickly extract the 5 URLs. Something to note here is if you only extract the domain, you might not be able to block it if they are using some cloud providers. You don't want to block AVS, for example, or Google Drive on your company network. Otherwise, your business won't be able to work. So this is why it's better to have the exact URL or exact route, so you can block what is known to be bad and not only the domain. So in this case, it's not very important, very unlikely that these are used for something useful. So the next step is to actually look at the file where it's dropped, so we can do the second step. And we can see here that it's 928.exe on the user profile. So the magic loop, so we have a malware, we put it on our detection system, we get the report back, we look at the report by an analyst, and then we extract IOC, so this is the URL, for example, then in some cases patch the malware so it can run and undetected on the automation system and do this loop again and again. So where we are on our infection flow, we can see that we have identified the URLs where it downloads the malware. So you can block this and look at our logs and say, okay, all of these systems downloaded this malware, so we might want to contain them too. So now for the file name. So, okay, we know that it downloads a file that's called 928.exe. We just have to look on our whole network for that file, and we're good, right? Not exactly. So here are the results from the sandboxes, and we can see that the name is changed on all of them. If we have a look in the square here, we have the actual, maybe this works. Okay, here we can see the MD file. So we can see MD5 hash. So we can see that it's the exact same file, but with a different name. And we can see that the names here of the file is different for all the sandboxes, and this is due to some anti-detection system by the malware, because it tries to change the name depending on the host name and other variables, so it's always different. So in this case, we can use the automation tool to see, okay, it spawns multiple processes, and we want to identify where it executes this when it changes the name. So that's when we go through the debugger and identify a list of file names here. And if we go a bit more into detail, we can see that it takes two of these names, two of these words, put them together, and that's the new name of the malware. So this is good for the attacker because now it's not only one file name that we have to find, but it can be up to 4,000, I think. So this is very costly. So it's better to know where to find the file. So execution path. So here again, we have our analysis tool that can help us with that. But in this, we have different results. So these two have the file on syswo 64, but this one, the last one, on ape data. So what's going on here? So here again, we know we have two passes, and we still need to do some manual analysis. So I will quickly go through here. So the malware basically looks at, can he create a service? If he can create a service, he sets a flag. If the flag is not set, it means that he was able to get admin rights. So he goes to the right branch here. Otherwise, it goes to the left. On the right branch, we can get the information of the function here. And we see that it calls shget folder path. And this function, basically, if we go to the Windows documentation, we can see that it looks for the well-known folders on Windows. So this is your $app data, etc. So now we just have to look at the parameters given, and we can see that it's sysled system 86, which is the Windows 32-bit system on a 64 system, which is the syswo folder that we found before. So basically, if he's admin, he will put a file there. But now, if we go and look at our automation tool, we see that we have here admin, and the folder here is local app data. So what's going on? So basically, here is where you have to know exactly what your tool is doing. Otherwise, you have some weird results, and you don't know what's going on, and you might not get the full picture. So in this case, the admin, it's just a username, but the malware was run as a user, the normal user, without admin permissions. So for completeness, I will not go too much into detail here, but the persistence mechanism works as follows. It tries to look if he has admin rights. If he has admin rights, it creates a service for persistence. So now you have a service running on that system that will call the malware every time. And if he's not admin, he will try to connect to the C2 server first. And in case it's successful, it creates a registry key. This registry key will basically start up the malware at boot or when he logs in. And if he was not admin and not successful at connecting to the C2 server, it will just kill the process. So no action. So if you're running this on an automated tool, you must run it as admin first, and once without admin rights to have both branches. And on one of them, you must enable network. So here is where it gets complicated with automation. Is malware uses several anti-analysis techniques to force you to run this in multiple different scenarios. So if you have some time and you have some resources, you can do this easily for the files that you receive. Other times, it's not that easy, and you must. It's better to do it manually and have someone look at it. So where are we here? So okay, we have the persistence and the file. So now we can identify where this file is. So with this information, we can already identify most of our breaches systems. So we know the connections. We can look at our logs and say, okay, these are all the systems that download this malware. And then we can look at file system. Maybe they change the URLs, so maybe not all can be identified. But if we look at the file name and the path, we can see where he was able to infect the systems and if he was running with admin rights. So if you only see systems that were running as user, it might not be that bad. Otherwise, if you see some running as admins, you might want to check those systems more carefully because you might spread elsewhere. Now for the C2, the automation tools will not be able to help because this is are highly obfuscated into the system, and you might need someone to manually analyze this to get these URLs. Okay, so to summarize, automated versus manual. So automated can be done really relatively quickly. So you can just put your files there, wait for the report, and then you can look at them later. Manually, it takes a bit more time. Of course, we are not machines. With automated solution, you can have results even without knowledge. So maybe you can have someone doing triage, just put files there, look at the results. If the results seem malicious or not sure, you might want to do some manual analysis on this. Otherwise, you might just leave it there. Manual analysis requires some technical knowledge, so you need some people with a bit more knowledge. The problem with some automated analysis, you might not have all the findings, and sometimes this can be okay, sometimes can be the difference between a successful incident response and a failed one. Automated analyses are victim to anti-analysis techniques. So it's automated, so attackers can also see how it works, and they can also create techniques to bypass them and prevent the system to work properly. As if you do it manually, you can actually look at that and the malware itself and say, okay, now it's trying to look at time executed, for example, and you can just change some bits and then bypass them. So automated tools are very easy and a good way to have results. So this is very good to triage your events. So if you have alerts, a lot of alerts, maybe you want to invest on a system like that, so you can put them and have a bit more knowledge into what's going on with these files. Fortunately, they are not always perfect, so you might miss on some command and controls, servers, file names, as we could see, and other capabilities. So basically, the best way to work with this is to actually have your files, put all your files on an automated analysis system, have the result, and then you can quickly improve on your manual analysis. As we saw before, the malware was spawning other processes. So this is a good way to say, okay, now I know that you will spawn like 3 processes before it actually does something. So you can just skip the first 3 and wait for the last one to actually have the interesting part. Okay. I'm done.
Okay, big round of applause for Christian. That was his first presenter talk at Swiss Cyberstorm, so you are welcome.